So today we'll see a problem through which we will get to the pattern, and this is a really famous problem and really good one. You can Google it up. So let's say we have a duck abstract class, and then there are methods quack, swim, and display. Each duck will be extending this abstract class, and therefore displays. Let's say that the display is a method that every duck will be implementing on its own. That okay, this is maybe like a duck, this is like a b duck, this is some other duck. So every displaying method will be have its own implementation in its own class, whereas quack and swim are common across all the duck classes. Therefore we have made this class as abstract, and this will have the implementation already, so that these don't have to, like if we had an interface over here, then everybody would have may make it own implementations. Therefore having quack and swim over here in an abstract class, we can have implementations here already, so these here in the concrete classes they won't get repeated. But let's say what's the problem now. So we have to add a fly method to this duck class, that the ducks need a method fly to be implemented. So what we can do, the first thing that will come to mind is like, okay, let's say that anyway this had all the methods, let's put a fly method over here, that all the ducks will also will be able to get it because they are extending this duck abstract class. So yeah, we just put a fly method, and now all the other ducks are extending it, and therefore they get this fly method. But now what would the, like when the problem scales, what is the next problem that we face? That let's say instead of normal ducks, now there's a rubber duck that we have that extends. We need a class of it, and therefore it extends this duck. But now, first of all, quack, it won't be quacking, it will be squeaking. So we'll have to implement a method, and we'll have to override it to squeak. Then we'll have to write another method fly, and we'll have to override, basically this will override the fly method of the actual abstract duck class. And therefore rubber duck now will have its own override to like no fly, it cannot fly, therefore this will be the case. So we are like, okay, we solved that. But what if there are like 50 more such classes such as rubber duck? Let's say tomorrow there's wooden duck, so it will also have to do the same, that it will have every duck has its own display method, so that is there. And then it has now it has to override the existing quack method. Here it was quack, but wooden duck can't quack, so it will be like no quack, it cannot quack, it will be just on mute. Then there's fly, it cannot fly, therefore we'll have to override fly method too. So now the actual problem is, as I said, there are more and more of these classes. When there are more and more of these types of classes, which where I have to again override quack or fly, and therefore I'll have to implement always these two methods in each of those classes. There will be lot of code repetition. Think of 50 classes, right? And there so we'll have to come up with something better. One might say that okay, that we'll construct some interfaces, that flyable will be an interface, quackable will be an interface, there will be the abstract class. Why abstract class? As I explained in the beginning, swim is common across all, so we don't want, if we make this an interface, everybody will have to implement swim, which is unnecessary, there will be code repetition. Instead we can use have an abstract class. Now you might say, okay, why not make flyable and quackable abstract classes too? Like whoever wants is like are taking them, and let them be abstract classes too. Why not? Like now currently when they are interfaces, all these are implementing, like whoever needs those methods are implementing those interfaces, but the actual implementation is done in the subclass itself. So the problem that we can't make is, for example, for quackable we cannot make it, because quackable in rubber duck will have its different implementation. Like quack in rubber duck will actually get be writing its implementation as squeak inside, and in normal ducks it will be like just actual quack. Therefore, quackable cannot be made an abstract class. Now you might argue that okay, flyable can be made an abstract class. Yeah, currently it can be, but let's say there are many more ducks. Like let's say there's a toy duck which flies with a rocket powered engine. So therefore, when the implementations are different, we'll have to keep these as interfaces, and then we cannot we'll have to implement those in the subclasses, and each subclass will have its own implementation according to its need. But now the code repetition is like too much, because every class I have to write fly, I have to write quack, whatever the methods it requires, I have to write those. So what is a better design pattern? What is some better structure that we can follow? So so this is the problem, file quack, which we'll have to implement each time, even though they might be similar for many classes. That's code repetition. Yeah, so it might be the case like here the fly was same, so it's taking code repetition for unnecessary means. So the design principle says that take whatever varies and encapsulate it and separate them from what stays the same. So currently if we see what is exactly varying, so swim is common across all. Display is something that every method anyway has to implement, like this is some xyz duck. But quackable and fly are something that somewhat similar, somewhat different in some classes. Like in some classes there is overlap, some classes have different ways of doing it. So therefore what we can do is we can abstract them out, and so pull out whatever varies, so different flying behaviors and different quacking behaviors. Therefore what we can do is we'll do an interface fly behavior, there will be an interface quack behavior, fly with wings, fly no way. So this class, concrete class, this is a class, this will be, these two will be interfaces, and these all will be classes. So these concrete classes will have implementation which tell the behavior, actual behavior, fly with wings or fly no way. So fly with wings will have the go fly, like whatever the implementation code is, and fly no way will have the implementation code of not flying. Quack, similarly in quack behavior, quack, squeak and mute quack. So whatever behavior that we want, we are like separating out, so that let's say the actual birds will use this concrete implementation. The ones that cannot fly, wooden duck and the rubber duck, can use this class, and these come under this interface. And the design principle is programmed to another design principle is programmed to an interface or abstract class, not to an implementation. What this is trying to say is, we'll understand more with the example, but earlier what we were doing is we earlier had the implementation or the more logic stuck into the actual super class of this, like the duck super abstract class, which was the super class of these, had the implementation of quack, had the implementation of fly. So fly, quack were coming from actual the super class. Or else next method, when we saw we were creating interfaces, we were creating those fly and quack in the subclasses. So either in the superclass or either in the subclass, which both in like the problem in both of these cases is whenever it's in the superclass or subclass having logic there, it becomes too much rigid whenever something new comes up and not flexible enough. Therefore, like when we program to an interface or abstract class means is, like earlier we had like this duck, quack, swim, display, fly. Display was like anyway every class has to implement. Swim is common across all. So what we do is we convert quack to perform quack, fly to perform fly method, and these will have the runtime objects of the interface actually. So interface, whatever we had defined, which were common, we had made them uh, pulled out from the varying methods from the duck abstract class. Whatever was varying we pulled out, and then we had created these interfaces. Now we can use those, because now when we have these fly behavior, we are not like these, we haven't selected that either if it is fly with wings or fly. We have said just it's just fly behavior. So at runtime we have the flexibility that either it can be fly with wings or it can be fly no way. So we always have that flexibility. Same goes with quack behavior, that we have the flexibility that it's not fixed, it's not rigid to a particular class or a particular implementation. We can change it at the runtime. So you might say how it is. Okay, so let's, for example, a small code, public abstract class duck, let's say this was the thing. Then fly behavior, we can keep the field private or public depending on how it is needs. Then we'll have a perform fly method, as we said here, perform fly, and what we'll do inside that is just call the actual whatever the runtime object is dot fly, because we had the fly behavior and the runtime object will be either of these, and we'll call dot fly. So either of these methods will get called. So you might say that okay, but when is fly behavior actually getting set? So we can what one of the ways of doing is that we'll either make let's say this is the a duck that extends duck. So when the public, when the constructor is being called, we'll initialize it with new like fly with wings for a duck. So for every duck we can say that okay, you can initialize during the constructor. Or even a better way could be that inside the duck class itself we'll have a method called set fly behavior, where at runtime we can give it the behavior of that fly behavior, whichever what the object, and then we can just initialize this fly behavior equal to fly behavior given, that whatever was given in the arguments will equal it to the actual the fly behavior that we have for that duck. So in code it will look like this duck, let's say, then this is just for naming that a duck. Let's say I wanted to keep this name, or it could be anything, and I take that object a duck. So now at runtime I do a duck dot set fly behavior, then we can do fly with wings, or let's say tomorrow there's a toy duck equal to new, and the type of its class will be, and then we'll be like toy duck dot set fly behavior new fly with rocket powered wings. So in that case what changes would be there, we'll have to add here another fly with rocket powered wings, and that will be like implementing the fly behavior interface. Therefore even then this won't change, we won't have to do anything here, because fly behavior anyway is a runtime holding the runtime object, like which will help gives the flexibility of having anything. So and everything goes similar for quack behavior. So the whole picture goes as we saw that we had duck class, we saw whatever was differing in that, what are the methods that vary and what remain constant. So whatever was varying we saw that was fly and quack, so we created fly behavior, quack behavior. Corresponding to those we created those methods as perform quack, perform fly, and then these are actually pointing, these runtime objects are pointing to these interfaces which have different these actual concrete classes, which this is actually the strategy pattern, and which is in that lingo is called as algorithms. But in simple terms it's just that we are want the flexibility, so whatever varies we first abstract out that, like we'll pull them out and we'll create concrete implementations for each of those behaviors, and then hold a runtime object corresponding to those behaviors in the actual abstract class. Now why abstract class, as I said in the beginning, so that each of the concrete classes won't have to implement which are common to all of them, like swim in this case, display anyway everybody has to implement, perform fly and perform quack will be something that uh, will be common to all here too, because we'll be calling them in a this way, that fly behavior dot fly, quack behavior dot quack. So we'll see more about this in the code.